Okay. I don't know if I can draw the whole, well, I guess I kind of got it, huh? All right, so let's do it. Okay. So I got it all written down. So how do we do repetitive? Repetitive nearest neighbor means you repeat, obviously. Nearest neighbor, right? So so that's really important. There's a difference between nearest neighbor and repetitive. Repetitive means you do it for each one. So you start at Boston, for example. Start at Boston, and you do nearest neighbor from Boston. Do the whole thing. When you're done, you start over nearest neighbor from Buffalo. Start over. Why is it not coming on the screen? Come on. What's the problem? Now you do each of them, one at a time. One at a time. Come on. Technology. All right, so starting from Boston, if I can get a screen. Thank you. Starting from Boston. So if you're at Boston, who's your nearest neighbor? Buffalo's 446, Chicago's 963, Columbus is 735, Louisville's 941. Who's your closest neighbor? Buffalo, right? 446. So you go to Buffalo, all right? Now you're at Buffalo. Starting from Buffalo, who's your nearest neighbor? 320, just looking across here, right? Right, looking at these guys. 326, which is Columbus. All right, and I'm supposed to be adding these up. What was the Buffalo number? 446. What was the Columbus number? 326. And then from Columbus, if you're at Columbus, what's your nearest neighbor? 209, Louisville. Louisville, that's 209. And then you've only got one city left. Once you got 4 cities, you got to go to the 5th one. What is it? Chicago, right? Chicago. So from Louisville to Chicago is 292. And then Chicago, you got to go back home to Boston. And how far is that? From Chicago to Boston? Chicago to Boston, 963. Wow. So add those up. Can somebody, I'll let you guys do it with a calculator. I'll go on to the next one. Somebody could add those up. So next, you start from Buffalo. So that's just the first. Now remember, we can rewrite any of those starting from Louisville. I know all the answers start. Don't worry about that. That's easily done at the end, right? They're loops. So you can start a loop anywhere. Remember that? This making sense? So start again now at Buffalo. So from Buffalo, who's your closest neighbor? If you're starting at Buffalo, here's how far your neighbors are away. Who's your closest neighbor? Columbus at 326. Everybody see that? I'm just looking at those numbers from Buffalo to Boston, 446, Buffalo to Chicago, 522, Buffalo to Columbus, 326, Buffalo to Louisville, 532. So the closest is Columbus. Columbus, and that's at I already lost it, 326. And then from Columbus, your closest neighbor is 209, Louisville. 209, and then from Louisville, your closest neighbor is, you can't do Columbus again, Chicago, right? You can't obviously go back, so you got to go to something new. That'd be Chicago. That'd be 292. At this point, I have 4 cities. Remember, once you only have 1 city left, don't mess around with anything. Just go to that last city and then go home, right? You guys tracking with me? I've got 4 cities. So I've only got 1 more city to go to. What city would that be? I don't know. Boston. Got to go to Boston. How far from Chicago to Boston? Chicago to Boston, 963. And then from Boston, you got to go home to Buffalo. Remember, this loop started at Buffalo. So from Boston to Buffalo, Buffalo to Boston, right here, 446. Okay. So did anybody add those numbers up? Nobody add those numbers up? Guys, we got to add these up. Get these answers. We got to get moving. Just hit the buttons on your calculator. Just type in these black ones. Who wants to do it? Let's make sure somebody's doing it. Who wants to do it? Who wants to do it? One at a time. Okay, good. Thank you. So you want to add up the black ones? Who wants to add up the blue ones? Got the blue ones? Great. Thank you. Add up the blue ones. Then I got to do 3 more of these. This is long. Super long, huh? You with me so far? Right? So add those up. I'm going to have to kind of erase this and squeeze them in up here, I guess. It's a long problem. These repetitive nearest neighbors are terribly long. Terribly long. So now, we've got to start from Chicago. So starting from Chicago, who's your nearest neighbor? Louisville. Louisville at 292. And then from Louisville, who's your nearest neighbor? 209 Columbus. And then from Columbus, see how I'm doing this every time? I just pick the lowest number. From Columbus, who's the nearest neighbor? It'd be Louisville, but we can't go back to Louisville. 308 Chicago. Chicago, 308. 308. And then from Chicago, now we have 4 cities. So I've got 4 cities. I only have 1 left. So if you only got 1 left, you got to go to that city. Oh, no, I can't go to Chicago. I've already done Chicago. Oops, let me back up. Yeah, I messed up. So from Columbus, can't go to Chicago or Louisville. Already been to them. Who else is it then? Buffalo. Buffalo for 326. Yeah, thanks. Now I've got 4 cities. All I got left is Boston. Got to go to that 5th city and then back home to Chicago. You have to. So from Buffalo to Boston is the 446. And from Boston back to Chicago to Boston, 963. That's a long trip, 963. All right, who wants to add up the green numbers? Anybody got a calculator handy? Want to add up the green ones? You got the green ones? Thank you. All right, so somebody have the black ones total?
Yeah, it's 2236.
22, I can't write over there. 2236. Okay, anybody got the blue ones total?
It was the same thing.
Same thing, oh. Must be the same trip, just starting somewhere else, huh? Interesting. Also 22. Is it the same trip, starting somewhere else? Yeah, you see it? See how it's the same trip? Start at Louisville. Louisville, Chicago, Boston. Louisville, Chicago, Boston. Next comes Buffalo. Swing around, then Columbus. The same trip. Those are the same loop, starting in different places, aren't they? 2236. We'll get the agreement in a minute. We have 2 more to do. We got to start. This is long. We got to start at Columbus now. So starting at Columbus. Columbus. So if you're starting in Columbus, who's your nearest neighbor? Louisville, 209, Louisville. Louisville, and that's 209. And then next, if you're at Louisville, who's your nearest neighbor? I don't know. Chicago. Chicago, that's 292. Then if you're at Chicago, who's your nearest neighbor? Louisville, but you can't go there again. Columbus, you can't go back to there again. Got to go to Buffalo for 522. Buffalo for 522. If you're at Buffalo, who's your nearest neighbor? 326 Columbus, but we've already been to Columbus. 446 Boston. I guess it's Boston. Oh yeah, we only have 1 city left. We have to go to Boston. What am I thinking? We have to go to Boston. 446. And then we have to go home. Home in this case being Columbus. How far from Boston to Columbus? 735. All right, who wants to add up the purple? Purple, you got that? Thank you. What's that which one?
2204.
Is the purple?
Yeah.
Oh, you already got it? Okay. 2204 for the purple. What was the green?
I got 2236.
2236 again. So that must be the same. Is it? Did you guys look at it? Is it the same loop? It's just starting somewhere else? No, it's backwards. It is. Same loop backwards. Start at Louisville. Louisville, go left. Louisville, Chicago, Boston, Buffalo. Louisville, Chicago, oh, no, a little different. Buffalo, Boston. But I guess it comes out the same. Just switches 2 cities. So it's not quite the same loop. All right, anyway, 2204 is the lowest total so far. We have to do 1 more. We got to start from Louisville, and then we're finally done. So let's start from Louisville. Okay. I'm just running out of room completely. So we'll go up to I don't know what to do. I'm just out of room. I'm gonna go up here, I guess, because I only need half the chart technically. So I'll go up here. Starting then, the amount of colors, it's a long problem. So, what am I doing? Okay, so I'll do this color. So starting from Louisville now. So starting from Louisville. Who's your nearest neighbor? 209, Columbus. Columbus, that was 209. Then from Columbus, who's your nearest? Oh, I shouldn't erase those. I'm just getting messed up here. All right, I'm just going to have to look at the chart on the screen here. From Columbus, the nearest neighbor is 308, Chicago. Chicago, I shouldn't have erased all those. Then from Chicago, the nearest neighbor is Louisville, but you can't go back there. Columbus, but you can't go there either. So Buffalo for 522. Buffalo for 522. Now you've got 4 cities. You only got one more. Got to go there. That'd be Boston. How far from Buffalo to Boston? Buffalo to Boston, 446. And then back home to Louisville. Boston to Louisville. Boston is 941. That's not going to be a cheap road, I don't think. What's that one at? Anybody get that one? What's that one add up to be? Total mileage. 2426. Thank you. So that's the worst one. Yeah, so what's the overall cheapest trip from the repetitive nearest neighbor? The 2204, right? So now I have to rewrite that answer starting from Louisville, right? Because they said, even though we got the answer a different way, rewrite this route starting, this one right here, the purple one, starting with Louisville. So I'm going to do that. I'm just going to erase all this stuff right here and say, okay, so that answer starting from Louisville is Louisville. And I'm going to go to the right. You could go left. It doesn't matter. Chicago, Buffalo, Boston. Buffalo, Boston, Columbus, and then, back to Louisville. There it is. Now, they could have it forward or backward on the answer thing. Everybody see that? So there it is. Louisville, Chicago, Buffalo, Boston, Columbus, Louisville. Back to the answers. D. Louisville, Chicago, Buffalo, Boston, Columbus, right? Yep, back to Louisville. There it is. You guys set a record. Am I teasing you too much? I've never had no one get the quiz question. Does that make sense? So that's a good one for this. So quiz questions don't matter. They're small potatoes, right? I'll give you a free one at the end. Everybody you get 5 points even just for getting just for clicking something. And then you get 10 points at the end. You'll have 15. You'll have an average of 7.5 for today.
But you can give us more time.
Anyway.
It's a good problem like that.
Yeah, well, on the test, you'll have the whole. Yeah, if I give another quiz one, I'll get more time. Yeah. But on the test, yeah, you'll have much time as you'll have an hour, to take the test. There's only going to be like one, probably. Mm-hmm. Well, only one from a big chart like this. That would be nearest neighbor. Yeah, those are tedious, huh? That took a long time. Questions on that? Does that make sense then? So do you understand the difference between repetitive nearest neighbor and just nearest neighbor, right? If they had just said, do nearest neighbor starting at Louisville, then I just would have started at Louisville and that's it. So repetitive, obviously you got to repeat them all. So we had 3 methods, right? Nearest neighbor alone, repetitive nearest neighbor, which we just did, and then cheapest link. That's that other one, right? So I'll probably give you that quiz tomorrow morning. Tomorrow afternoon, tomorrow at the start of class. All right, well, that was 20 minutes on our quiz question. We better get moving to chapter 8. So practice that. This week, our plan is, you have the syllabus. Practice exam day is tomorrow to go over. Practice exam number 3, and the real exam is Wednesday. Okay. Today is the big chapter 8 day. We've begun it, but we really need to finish it. We have an hour and a half. Chapter 8 is challenging. It is. People have trouble. The next exam, take a look at the practice exam. It's already out there. I'll give it to you tomorrow, but you'll see what I mean. Half of it is not multiple choice. This will be the only exam where I have some not multiple choice. The chapter 6 stuff we just finished, nearest neighbor, all that, that's all multiple choice. And you'll see the practice exam tomorrow. But the chapter 8 stuff is not. because you'll see in a minute, they're long charts you got to make. So I'm just going to give you 4 of them or something like that, 5. I don't know. You see what's on the practice exam, whatever it is, and you'll just make the charts and turn that in for grading. So that's challenging for people. I'll show you why as we go. All right. So anyway, so back to this again. So remember how we take this and turn it into one of these kind of arrow diagram things. Remember that? Let's do it one more time. It's been 4 days. Although I know you haven't thought about anything but my math class, right? All right. Me either. All right. So no more lying. Let's get going. So remember the precedent task pre's before, right? So F leads to B. And F also leads to C, and G leads to D. So I'm going to start making, as I go, I'm going to start making those arrows, right? You just make them over here on the right. F has to point to B. Does that make sense so far? Because it's precedent, means before. Pre means before, right? So F, whatever job F is, I don't know, putting the flooring in, has to be done before the walls are built on the house. Whatever, you know. Some kind of job that must be done before B. Before task B, preceding it is task F. So F leads to B. Good? And F also leads to C. Right? Just a third arrow. G leads to D. Where do you put that? I have no idea. So I'll just go G leads to D. Maybe I'll move it later. Maybe not. Good. Next one. C leads to E. Here's C. Move that forward to E. A and H both lead to F. 2 separate arrows. Every precedent up is an arrow. A to F and H to F. Both those to F. I don't have, here's F. So A is back here, leading to F, and H is back here, leading to F. They both lead to F. A and H both lead to F. Okay. F leads to G. F leads to G. Now, I could just put it like that. I mean, that's okay. I'll give you credit on the test and everything. It might be a little easier to move it forward. F leads to G. And what did G lead to? D. Like that. It might look neater if you need to actually work with it later, but I'm fine with however you do it, as long as you get the right arrows, you know. And then that's all. That's all the arrows other than the start and the end. Everybody good so far? Remember how that works? Just fill in all the arrows. Now, the start's going to be over here, obviously, and the end's over here. And how do you know what points to what? Well, the start points to anything that doesn't already have an arrow pointing to it. So A doesn't have an arrow, H doesn't have an arrow, so that's it. So you can start with A or H, that means, because there's nothing leading. A has no precedent, and H has no precedent. Nothing before that. So they can be started. They can be the start, right? And then E and D both lead to the end, because they don't, and also B. Anything that, don't forget B. Anything that doesn't lead anywhere else goes to the end. It's nothing comes after it, right? So it's at the end. It leads to the end. Is that good? Some people like to move when something's near the end. They like to move it forward. I don't care, you know. But if you like that better, I guess it does look a little better. You know, put what was it? B way over here. If that's easier for you to look at it that way, that might be nice. Whatever. It's all good with me. Does that make sense? Which one of those? Oh, you can see down here. This is the same chart, isn't it? They just kind of organize. See how they organize it a little different? So I'm saying it doesn't matter. As long as you have the same arrows, it doesn't exactly matter how they're situated. They did a very nice diagram. Is that good? Be able to do that part? So again, this will not be multiple choice. These questions will not be multiple choice. You'll see on the practice exam. I'll just give you this and say, draw me the chart. And then you just draw the chart. Good? All right. Okay. 8 experiments need to be carried out. One of the experiments requires 10 hours to complete. 2 require 7. 2 more require 12. 3 experiments require 20. In addition, the 10-hour cannot be, oh boy. Okay. I'm going to start, what do we got? Okay. 8 experiments. Okay, so there's a 10-hour. There's 2 7. There's a 10. I'm just going to do this first. So there's a 10. There's 2 7s. 2 12s. And 3 are 20 hours. Okay, 3. And that's all of them. Okay. The 10-hour cannot be started until both of the 7 hours have been completed. Hold up right there. What does that mean? The 10-hour cannot be started until both of the 7 are done. So that means both the 7 point to the 10, don't they? The 10 can't be started until both the 7s are precedent. They're done before, right? Good? So I'll move the 10 over that way. And then what's the next fact? The 12-hour cannot be started until all 3 of the 20. So you got all 3 of the 20, both leading to the 12-hour experiments. Okay, so I'm going to have to put all 3, I don't know how to do it here, move these over. All 3 of the 20, 20, 20, 20. All 3 of the 20 lead to the 2 12s, don't they? So zip, 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 and zip, zip, zip. Right, you got to do all 3 of the 20s before this 12 and all 3 of the 20s before that 12. Is that good so far? See how that works? Right? Okay, so it's that diagram, it turns out. Oh, I got to put the start and the end on. I didn't put the start and the end. So then the end over here, what's the end? Well, anything that doesn't point anywhere else, so these guys. And the start is these guys. There we go. Yeah. So that's another way of writing the same diagram, I guess. Yeah. Yeah, it is. We good? I didn't put letters on them, but the numbers are there. Is that okay? Could you do that? Well, make sense? All right. Yeah, Hector.
So the 20s that you have there, how come they need to go to both the 12s?
Yeah, I'm just going by that sentence. It says the 12-hour experiments cannot be started until all 3 of the 20.
Yeah, but I'm saying the 20, you see how one of the 20s goes to both 12s, each of them go to both 12s?
Yeah.
Is it always going to look like that?
No, that's just the only way it could be true to that sentence. Does that make sense? So see how they said the 12-hour experiments, plural, so that means both of them, cannot be started until all 3 of the 20.
Then I get that part, but the fact that each 20 is going to both 12s.
Okay, here, let me do it this way. What if, for example, you had that 20 only going to the top 12? You would not be true to that sentence.
Okay.
Do you see what I'm saying? Does everybody see? I'm sure it's not just Hector. Hector's ace in everything, so I'm sure if he's confused in any way, everybody is. So does that make sense? That's how what needs to be. If even one of those was missing, it would not be true to that sentence. That's what that sentence means, right? Right? The 12-hour experiments, both of them, meaning this one, the other one too, or I'll say this one may not be started until all 3 of the 20 are done. If I don't have that arrow down, then I'm saying, hey, you can start as soon as these 2 are done. No, that's not what that sentence said. Does that make sense? If I left out that arrow, for example, because a lot of people think, exactly what Hector's saying, they think, hey, why are both going to all 3, or why are all 3 going to both? Why don't they just go to 1? Well, because that's what that sentence means, right? Because it says the 12 hours, experiments, both of them, so this one also, cannot be done until all 3 of these. If I only have 2 arrows going here, then what I'm saying is you got to do these 2 20s, then you can do this 12. I don't care about that one. He's only for the other one. That's not what it said. That makes sense? Being true to that sentence? Good. All right. Let me copy it in here for you. Okay, yeah. So 8 hours, 9 hours, 8 hours, 5 hours. So if you add all those up, if you add all those times up, what are you going to get? Some kind of big number. I don't know what it is. 21, 26, 34, 40, 50, 63, 72. Is it 80? I think it's 80. So I added them up. I'm pretty sure it's 80. So what it means is they're saying a project has 11 tasks, has a bunch of different tasks that need to be done, and that's how many hours each of those tasks take. If you add all those up, that's 80 hours of total work that needs to be done to do all the various tasks. Is that good so far? Then when they say 4 processors, let me start introducing that lingo. That means like 4 people. Or 4 robots, or whatever, 4 processors, let's just say people. 4 people are going to go work on these various jobs. We're about to begin the actual part of this chapter, which is the role of a manager assigning employees to do different jobs. So if 4 people are going to go work on this job, and do all the tasks, which add up to 80 hours. And at fin means they're finished. Oh, it even says it, finishing time. That means it takes them, the finishing time is 29 hours. 4 people worked for 29 hours. Let's multiply that by 4 and get total hours that were worked. 4 times 29 is 36 and 80. 116? 116 hours total. But there was only 80 hours of work that needed to be done. So there was some wasted time. That's exactly what we're trying to minimize as a manager, trying to have time not be wasted. So let me slow down for just a minute. Am I going too quick? Does that make sense what I'm saying there? Right, so there's 29 hours. It says the finishing time, these 4 people went and worked on these tasks and they finished them all, which are 80 hours of tasks. They finished them all in 4 times 29, 116 hours of total work. They finished them in 29 hours, but that was 4 people working for 29 hours. Total of 116 hours of work were done, but it was only 80 hours of tasks. So subtract the 80, 36 hours wasted, or what we call idle time. So in other words, because of bad management, some employees were standing around waiting and they couldn't begin their job until something else was done first. That's what we're trying to minimize with our management. Does that make sense? What I'm saying? So is that their question then? What is the idle time? Yeah, so that's how we got that 36 hours. 36 hours idle time. And then question B, choose the correct answer. Explain why a schedule with 4 processors must have a finishing time 20 hours or more. Does that make sense? If 80 hours of work, I added up all the 80 hours of work, and you have 4 people, 80 divided by 4, that's 20 hours per person, right? So even if everybody is working perfectly all the time, the soonest they can get it done is 20 hours. Is that making sense? Because if 4 people work for 20 hours, they'll do how many hours of work? Maybe if I said it that way, it'd be easier. If 4 people work for 20 hours, that'll be 80 hours of work, which is exactly how much work there is to do. So they're not going to get it done sooner than 20 hours, right? They can't get it done in 19, because 4 times 19 would only be 76 hours of work. There's 80 hours of tasks that need to be done. 4 people, the best they're going to do is 20 hours as a team. Does that make sense? So that's what they're asking in part B. Why does it take 20 hours? They're saying the 4 processors working without any idle time would take 20 hours to complete. Therefore, it's at least 20 hours. Yeah. That's the correct answer. Does that make sense how that's working? So we have 80 hours of tasks, and there's 4 people, so they'll need to work 20 hours as a team at least. That'd be the best perfect management if their team got it done in 20 hours. Let's go on. That's kind of a... Oops. That's the wrong one. Okay. So there we go. So, all right. So here is our first scheduling. So this is the main thing we're doing right here. All right. I hope you'll copy this down with me. Think with me really carefully through these. These are really important. So copy that down, first off, on your paper. This is problem number, what number is this? 4, thank you. This is problem number 4. What you need on your sheet is this up here. This is called our priority list. I'll explain. It's our priority list. Problem number 4. We're in section 8.2 right now, 8.2. This is our priority list, and this is our arrow diagram. So copy that arrow. This is the end. Over here, this says end. So put your arrow diagram down, and then we're going to make a mapping with 2 processors. So, all right, You ready? I'm going to do processor number 1 and processor number 2. And what I'm going to do is I'm going to try to just map out the time here. All right, so we're the manager, and we're going to schedule the employees, the 2 employees. This is processor number 1 and processor number 2, which means like employee number 1 and employee number 2. We're the manager. This is all about wise management, using math to manage things efficiently. And we're going to tell the employees which jobs to work on at which times to try to do it efficiently and not have too much wasted time, too much idle time. So here we go. So first off, let's make sure you understand how the arrow diagram works. Job D, for example. Job D cannot be done until A is finished first, right? And what about job B? That's a little more tricky. You have to finish both B and C, not one or the other, but both before you can. That's a common mistake people make. Everybody smelling what I'm stepping in there? Is this saying the South? Right? You tracking close with me? Everybody seeing that? You cannot do job E until both B and C are done. Both of them, not just one or the other, but both. So maybe that's the walls and the plumbing or whatever before you can do the roof. You know, whatever. They both have to be done. Okay, and et cetera, et cetera. So that's what the arrow diagram means. The arrow diagram is the main guide that we will use. The priority list is also a guide, but not as important. Okay, here we go. Processor number 1. We're the manager. Which tasks can we start with? Well, A, B, or C, right? Those are the ones that come from the start. You can't start with D, you can't start with E, because you got to do other stuff first. Can't start with F, can't start with G, you got to do other stuff first. Okay, so we're going to start with either A, B, or C. Well, how do you decide which one? Well, processor 1 has A, B, or C. We choose for him. How do we choose? Well, when you have options, we have options right now. Most of the time we won't have options. But right now we have 3 options, jobs A, B, or C. You go up to your priority list and you say, okay, based on the priority list, which one's a higher priority, the highest priority, A, B, or C? Oops, what was that? I just blew it. What just happened there? There it is. B. See B right here? Oh, I did that again. B. See B's first in my priority list? So that means we start with job B. Everybody tracking with me? Because B comes before A and way before C in the priority list, right? Here's B, here's A, here's C. B's a higher priority. So when it comes to options, B's going to go first. All right, so how long does B, I'm going to give processor 1 job B. How long does it take him? Yeah, that's the 5 in the parentheses is 5 hours. So let me do that. What we're going to do, guys and gals, is make a little number line. So I'm going to go 1, 2, 3, 4, 5. Like that. Oh, I might need more room than that. Same thing down below. 1, 2, 3. Keep them lined up. Make sure you keep these lined up with each other. And job right there, there's the end of job B for processor 1. Does that make sense so far? I just gave processor 1 job B. Remember, this will not be multiple choice on the test Wednesday. It'll be just draw me this chart. This will be the main way you get points in this chapter, is drawing these charts. So processor 1 does job B for 5 hours. Now, I got to give processor 2 a job. Processor 2 needs a job. So what job could I give processor 2? Yeah, which jobs are available? A or C? Because I already gave B to processor 1, huh? Oh, by the way, to keep things simple, we never break jobs up. We never do half times or anything like that. Just keep it simpler. So processor 2 can do A or C. So which one will we give him? We have options, A or C. Who's a higher priority, A or C? A is. We go to our priority list. A is a higher priority than C. So we give him job A. How long does job A take? 8 hours. So 5, 6, 7, 8. A's an 8-hour job. Does that make sense so far? Okay, now, here's where it starts to get a little complex. What you need to do is you just need to keep moving forward in time. So I'm going to go to the, every time somebody finishes a task, like that's like an employee coming back to the manager and saying, what's my next job? So right there, I'm going to go back to time 5 because that's when the first job is completed, right? The first task. Job B is done at 5 hours. Then this employee 1, processor 1, comes back to the manager and says, all right, boss, I'm done with job B. I'm ready for a new job. So how do we know what new job we're going to give processor 1 at 5 hours into the project? How are we going to figure that out? Well, go over to the arrow. It's always about the arrow diagram. Don't go first to the priority list. That's the mistake I've seen students make in the past. They get kind of obsessed with the priority list. Really, probably through the rest of the problem, I'll hardly even look at that priority list. It's mainly this arrow diagram. That's the first thing that guides us. Only if he gives us a couple options do we then go to the priority list and say, okay, we have options, which one? Usually he won't give us options. So anyway, come over to this arrow diagram and look at where you're at on the arrow diagram. Right now at 5 hours, job B is done, and job A is being worked on by processor 2, right? So what jobs are even available at this time? Only C. See how we have no options? I'm not going to go to the priority list. There's only one job available. Only C, right? Because B just got done at 5 hours, at time 5 hours, right here. Job B just got finished. He's done. You cannot go on to E yet. Why not? Because C's not done. Remember, E and C have to both be done? I'm sorry, B and C have to both be done before you go on to E? So we can't do that. We can't go on to E or D or any of those back there. And A is already being worked on, so the only option is job C, huh? This is the only option. So I'm not even going to go to the priority list. Everybody see that? Because the arrow diagram's only giving me one choice. That's what he usually does. We'll probably hardly ever look at the priority list from now on. So C for 9 hours now. That's a 9-hour job. We're going to give it. So if you're at 5 hours, add 9, that's 14, right? 6, 7, 8, 9, 10, 11, 12, 13, 14. At 14 hours, give him job C. So from 5 hours to 14 hours, for those 9 hours, he works on job C. Is that good so far? And next, we ask, if you're ready to go on, what's the next job that's finished? Right there, job A at 8, huh? Is that good? Job A is done after 8 hours. So then you got to kind of go to the arrow diagram and say, okay, what's going on in the work at 8 hours? Well, right at 8 hours, job A gets finished. So let me go up here and cross off job A is done. Job B has already been done. C is being worked on. Let me fix my arrow diagram. So A is done, B is done, C is being worked on by processor 1. That's the state of affairs at 8 hours, right? At 8 hours, B and A are done, C is being worked on right at that time, huh? So B and A are done, C is being worked on. So, arrow diagram, what jobs are even available at time 8 hours? Can you tell it's only D? Only D. Again, E's not available yet because you got to finish B and C before you can get to E, huh? So if A and B are done and C's being worked on, the only job available is D. The only job, no choices again. I'm not going to that priority list. You only go to the priority list if the arrow diagram allows you to have a couple options. Then you say, okay, what's the highest priority? So I'm going to go to D. That's all I can do. D is a 12-hour job. So 8, add 12. That's what, 20? Going to take me all the way to 20 hours? So 9, 10, 11, 12. Notice how I'm keeping them lined up. 13, this is 14, just like above. Keep them lined up. 15, 16, 17, 18, 19, 20. There we go. So job D goes all the way from 8 to 20 hours, 12-hour job. Processor 2 does. Again, we never break up a job. We're just keeping this simple. Never break up a job between two people or anything. That'd be too complex. So keeping it simple. Good to there? So can you take the next step? Go ahead and do the next. Let me let you do one. Do the next step, which means who's the next employee that comes back to the manager and says, I'm ready for another job? What's the next completed job in time? Job C at 14 hours. All right, job C at 14 hours. So at 14 hours, what's the state of affairs? Job C just got done. Job D is being worked on by processor 2. Why don't you figure out what comes next? Okay, so where are we at? What jobs are available? Only E, huh? Only E? Does that make sense? Because right now at 14 hours, is that where I'm at? Yeah, 14 hours, right here. I'm right here. At 14 hours, A, B, and C are done, right? I've crossed off A, B, and C. But right at 14 hours, D's still being worked on by processor 2, huh? It's not done yet. So F's not available until D's done. D's not done right now, not at 14 hours. So F's not available. Of course, G's not available. The only thing available is E, huh? So got to take E. Is that making sense? So got to put E up here. E is a what? 6-hour job, so that'll finish right at 20, won't it? 15, 16, 17, 18, 19, 20. They're both done at 20. Yeah.
Before you go to E, do B and C have to be on the chart?
Yeah, right. Had to be done and on the chart. Exactly. Well said. Well said. Yeah. Right. Yeah. B and C have to be done before we can go to E, and they are, right? B and C are both done before we go to E. Doesn't have to be done by the same processor. It just has to be done by somebody before E can be started. Yeah. Exactly. Is that good? And so then now go forward in time to at 20 hours, both employees come back to the office at the same time saying, we're both done. We're both ready for a new job. Whenever they came at the same time, you just always start with processor 1. He always goes first, just keep things orderly. So processor 1 will go first. So, and what are you going to give processor 1? What are your options right now? At time 20, I got to update the arrow diagram. At time 20, D and E are both done, huh? As far as, and A, B, and C. So both F and G are available, huh? Both jobs. So for processor 1, who's always going to go first when they're both there at the same time, processor 1, is he going to get job F or job G? And don't just say, well, F comes before G, so no. That's when you go to the priority list, right? It's when you have options, and I have options right now, right? Because I can give him F or G, can't I? So I have options, so you go over to the priority list. Which one's a higher priority? F comes before G. So it's for that reason that we give processor. Now, I know you're probably thinking, well, it doesn't matter. They're both going to do something. I know. And of course, you're right. It doesn't really matter in this situation. But that's the rule we'll always follow, is that, go to the priority list when you have options. So F comes first. Well, it's only a 1-hour job. So just F, 21 hours, done. And therefore, G will go to the bottom, processor 2, done at 22 hours. And there we're done with everything. Everybody good to that point? That makes sense? And then what is processor 1 going to do during that last hour from 21 to 22? this right here, is idle time. Because there's no job for him to do and everything else is done, right? So that's only one wasted hour. That's really good management. We only wasted 1 hour. You'll see some of these charts we'll do will have big chunks of wasted hours while an employee waits for another job and there's nothing available, right? And then we'll talk about how to manage things more efficiently. So that was a really good, very efficient, only 1 hour of wasted time, only 1 hour of idle time. And there's a chart. That would be what I'd ask you to do on the exam on Wednesday. Questions I can answer on that. Does that make sense? Good. They're going to change everything up here. You know, we're just getting our feet wet. Then they're going to go to 3 processors, and they're going to say different kind of priority lists, and they're going to do special fancy things. But we're just getting going. So number 6. Okay. So here we go. The priority plan is called decreasing time. So instead of giving us like a list of priority like A and then C and then D or whatever, they're saying do it by decreasing time, meaning higher times go first. Does that make sense what I'm saying on that? And that kind of makes sense if you think about it, huh? Jobs that are bigger, you want to get started on sooner, right? That's what they're saying. That's what they'll call it the decreasing time algorithm, meaning the higher things first and then decreasing over time. Okay, so here we go. 2 processors again. Processor 1, processor 2. How about, would you like to try just the first step and then stop, and then I'll do it? We'll kind of go lockstep through this thing to kind of get you more and more comfortable with them. So see if you can give the first jobs to processor 1 and processor 2. Yeah. What's that? Yeah, it's decreasing time, and I'll talk about that. I know that seems kind of weird. I'll talk about that right now. Everybody got the thing written down, the arrow diagram? This is number 6. I'm sorry, I should have put that somewhere. This is question number 6. And so I hope you drew that arrow diagram on your number 6. And then I'll help now. Yeah, so, and I'll talk about what decreasing time means. Let's actually try this one now. So, all right, so we're supposed to give a job first to processor number 1. What are our just always arrow diagram first. According to the arrow diagram, what are the options for processor 1? What jobs can you start with? It's A, B, or C, right? You can start with A, B, or C. Okay, well, how do you know which one? Well, decreasing time, what that means is you start with the highest job you can. So out of A, B, and C, right, my options are A, B, or C. So whenever you have options, and I do have options right now, right, then you go to your priority list. So which one's going to go first? C, because it's the most hours. It's 9 hours, right? You start with that. That's what I mean by higher times go first, called the decreasing time plan or method or algorithm. So yeah, give job C. So that's a 9-hour job. So 1, 2, 3, 4, 5, 6, 7, 8, 9. It's a 9-hour job for C. So processor 1 does that 9-hour job. Good. All right. And then what job do you give to now processor 2? He needs a job also. What options do we have for processor 2? We already gave job C, huh? So we have A or B. And so we have a couple options. So we do our priority thing. Our priority thing in this problem anyway says decreasing time. So on the real test, I'll give you like a priority list that says like alphabetical maybe, like A before B, B before C, you know, like that. Then I'll give you another one with decreasing time. You know, that's so you'll, you know, this is how the test will be. So last time they gave me letters in a certain order. It was some kind of weird order. Now it's decreasing time. So which one, A or B, which one is our priority? It's going to be B because that's a higher time, right? Do the higher time jobs first, decreasing time. So B is a 2-hour job, so I'll go 0, 1, 2, job B. B is a 2-hour job. Try to keep your marks, your time marks, your ruler, lined up with the top and the bottom. 1, 2, see how they're lined up? So, okay, so B was a 2-hour job. All right, can you take the next? So we gave both the processors a job. Can you take the next step? So whoever comes back to the manager and says, I'm ready for another job. Okay, so who comes back to the manager first and says, I'm ready for another job? P2, processor 2, because at 2 hours, he's already ready for another job. So, okay, so he's ready. What's the state of affairs at that moment? Well, B is you always want to keep going up to the arrow diagram. I really encourage you to do that. What you really need on this section more than anything is carefulness. Because me too, I mess up on these. It's real easy just to, well, not yet. When they get to 3 of them and more stuff going on, it's easy to forget something. So I'd encourage you to mark stuff on your arrow diagram. Just get in habits of carefulness. You won't have a time problem. You'll have a carefulness problem. You'll forget one little thing and then the whole chart's off. So be careful. Go up there, say, I'm marking them off. I'm doing all that kind of stuff. Don't just look at it. I actually do that. Mark it off. So B's done. C's being worked on by processor 1. So if that's the state of affairs on the arrow diagram, what job or jobs is available? Only A. Does everybody see that? Only A. Why not E? Well, we're not done with C yet. Only when we're done with C can we go on to E. It's being worked on, but it's not done. And we can't go on to D until both A and B are done. Does everybody make sense of that? We cannot go on to D until A and B are both done. So the only job available is A. I don't need to look at any priority list, that means. There's only one option from the arrow diagram. Does that make sense? The arrow diagram really rules. And we only go to the priority list secondarily if the arrow diagram allows us to have options. Right? So the arrow diagram said, hey, your only choice is A. Get going on job A. Okay, that's a 1-hour job. That's a quick one. Boom, done. So an hour later, that employee comes back again and says, I'm done. Okay, cross out A. We're at 3 hours now. Jobs A and B are done. C's being worked on. What job is available? I'll let you take the next step. Yeah, just D, huh? Only D. Let's go ahead and put down D with the appropriate number of hours and everything. D's a 12-hour job, huh? D's a 12-hour job. So add 12 to 3. Right, add 12. 15, going to go to 15. So 4, 5, 6, 7, 8, 9 is here. 10, 11, 12, 13, 14, 15. So at 15 hours, job D is finally done. So 12-hour job takes us all the way out to 15 hours for processor 2. Good questions thus far? Okay, we're gonna take the next step. Look at who the next employee is who comes back to the office and says that he's ready for another job. All right, so what's the next, so right now D's being worked on by processor two. Processor two. So what's the next job of, oh, and C has been finished. Let me go forward here. So I'm at 9 hours, right? I'm going forward. The next employee that comes ready for another job is at 9 hours. Employee one, processor one comes. He's done with the C. The A and the B are done. D's being worked on by processor two at that point in time. Okay, and processor one's ready for another job. So what jobs are available? Yeah, E, just E, huh? E, everybody see that? Only E is available because C is done now, right? At 9 hours, C is done, so E is available. Give him E, it's an 8-hour job. 8 hours, so go ahead and take that next step. Give him E, it's an 8-hour job. That'll let you do that. And then see if you can sign the next job. Take another step. Okay, so E's an 8-hour job. Give him E, so that'd be 8 hours. So 9 add 8 is 17. And take us out to 17, huh? So whoop, my line's not so straight there. Take us out to 17. So this is a 15. So 10, keep them lined up. 11, 12, 13, 14, 15, 16, 17. Take us out to 17 hours. That was job E, out to 17 hours. All right, move forward in time to the next job that's available. What's the next job that's available? Yeah. D's done. So the next, the employee comes back, D's done, right. And so we cross off the D. And E's being worked on at that moment in time by processor one. Everybody good with the state of affairs? Right there. Right now I'm at 15 hours. So you just keep going to the next employee who comes to your office for a new assignment. So at 15 hours, A, B, C, and D are all done. E's being worked on. A, B, C, and D are done. Processor one's working on E. So what job's available? Only F, huh? Only F is available at that point in time. Is that good? Only F, not G yet, because we got it. We're still working on E at 15 hours, right? Right? He's up here still working on E, processor one. So only F, 5-hour job. Add 5, take us to 20. So 16, 17, 18, 19, 20. Take us to 20 hours. That'll be job F. Take us to 20. Like that. Okay. Is that good? Who's the next employee that comes to the office? Go ahead and do the next one. Well, that's going to be just G, isn't it? Basically, at 17 hours, job E is done. And so G is left. 6-hour job. Add 6. What's that, 23? So 18. Whoops, that was a little too big. 18, 19, 20, 21, 22, 23. So 23. At 23 hours, that's job G, like that. And then that's it. That's all the jobs. So bring this one forward. So the last 3 hours are going to be idle for processor 2, aren't they? 3 hours of idle. So sometimes they'll ask you how many hours, well, almost always. They'll ask you how many hours of idle time, so 3 hours of idle time. So that's pretty good. That's really not much waste at all. Is that good on that? Does that make sense how to map those out?
Wait, so just to
Mhm.
clarify,
Yeah.
like I messed up and I put the G on processor two, so then I flipped G and F.
Yeah, and why could you not? Yes, I'm glad you're asking. Let's talk about that. Yeah, why is it, how would I know? Let me back up a little bit. How would I know that it's not okay, like you kind of had G right there? Why would it not be okay to put G right there? Why is that not okay?
Because you have to finish E first.
Exactly, good job. Exactly. Yeah, you can't do G until E is done first. And at 15 hours, E is still in the middle of being worked on. E's not done until 17 hours. Exactly. Is that good? Just all about the arrow diagram. It really is. That's the big thing that rules. Yep. Good. So instead, D had to go on to F for 5 hours, put it back the way it was, and then E did G. E led to G at 23. This was idle. Yep. Good. Other questions on that one? All right, so that's number 6. Shall we go back? Got about 35 to number 5. Okay, so this is the priority. Instead of decreasing time, they're back to just like listing out certain jobs that need to be done before other jobs. They change their mind from problem to problem, how they have us do the priority list. Okay, this is 3. N equals 3 processors. So that's a little harder. We're only going to do maximum 3. So we have processor 1, processor 2, and processor 3. We have all 3 of them. Okay, so 3 employees. I'm going to manage this job. There's your priority list. Give it a try. Let me let you start. I'll give you a second to start on that. Is it making sense? Okay, so processor 1 first. Which jobs, now here's a mistake. Let me show you over the years, some of the mistakes I've seen to, maybe this will help. Sometimes in the past, I've had students, they'll look at the priority list, and really you shouldn't look there first. You should look at the arrow diagram. But anyway, they'll look there first and they'll go, okay, D's first, I'll give D to processor 1. That's not right, huh? You can't do it that way because it's really, again, the arrow diagram. That's the main thing, huh? It's the arrow diagram that's the main thing. And the arrow diagram says you gotta do A, B, or C first. You can't start with D. You can't even do D until after A has been done, huh? So again, the priority list is not the main thing, right? It's the arrow diagram. That's the main thing. Always go here first. Only go back to the priority list if the arrow diagram gives you options. Okay, so starting at the arrow diagram, which jobs are available? A, B, or C, huh? So which one, so I do have options for processor 1. I can do A, B, or C. So then, trying to decide which one to give processor 1, A, B, or C, then I do go to the priority list because I have options. The arrow diagram is giving me choices. So I say, all right, which one's the highest priority, A, B, or C? Well, D's the highest, but he's not in the choices there. C. C's a higher priority than either A or B. Right, among those three. And that's my only choices. I can't choose D. D's not allowed yet. Arrow diagram says no. Right, so the choices are A, B, or C, and among those three, the highest one, the most important of those three, is C. So you start with C. C's a 9-hour job. So it'd be 1, 2, 3, 4, 5, 6, 7, 8, 9. 9-hour job, C. There we go. Processor 1's getting C for 9 hours. What about processor 2? So processor 2. He has A or B. Which one's highest priority? A is that priority over B. So that'd be 8-hour job. So that'll go 1, 2, 3, 4, 5, 6, 7, 8. Again, keep them lined up. It's really important that they're lined up with each other. So that'd be job B, finishes at 8 hours. And then finally, processor 3 is going to get the job, A. Oh, wait, did I just do the wrong one? That was A. Yeah, I was supposed to say A, wasn't it? A. And then B. B will be down here, 5 hour. 1, 2, 3, 4, 5. Oops, I'm getting not lined up very well. Try that again. 5 hour, 1, 2, 3, 4, 5. 5 hour. Processor B, 5 hour. Good so far? For the first assignment of jobs like that, we just did it by priority levels. Okay, so who comes to the boss first, ready for another job? Going to be processor 3, huh? Right here at 5 hours. For he's the first one done, right? So he comes back to us, the manager, and says, "Okay, I'm ready for another job. Ready for another job." So, are you caught up, or am I racing ahead of you? I don't want to give you a second. We all good? Because I want to help you think through this. Now, it's just a little more tricky. So, what's the state of affairs at 5 hours? At 5 hours, what's the state of affairs? Well, job B is done. Job B is done. A and C are being worked on, but they're not done, huh? A is being worked on by processor 2. And C is being worked on by processor 1. So what jobs are even available? None. None. Do you see that? Because up here, the A's not done yet. Processor 2 is just working on it, so D's not available until A's done. B's done, but you can't go to E until also C is done, and it's not done yet. It's still being worked on. So there are no jobs available. So what you do is you just fill in idle time up to the next time somebody else comes to the office. Next time another job is done. Does that make sense? There were no jobs. So here's where we're getting into poor management, right? There were no jobs available for processor 3. So we had idle time. Nothing available. Okay, come up to 8 hours now. Come up to 8 hours, and then job A is done. So let's update the state of affairs. Come up here. Job A is done now. At 8 hours, job A is done, job B is done. Job C is still being worked on. Not quite done at 8 hours, right? And we have 2 processors sitting in the boss's office, the manager's office, ready for jobs. So processor 2 will be first. It doesn't matter that processor 3 has been sitting there longer. Whenever you have 2 people available, you just start on the top and go down. Does that make sense? That's sometimes a confusing point for people. So both these guys are available. Processor 2 and 3 are ready for a job at 8 hours. And even though 3's been there longer, it doesn't matter, 2 is higher, so 2 will go first. All right, so what job are we gonna give processor 2? What jobs are available, looking at the state of affairs? Only D, right? Only D is available, because now job A is done. So we will give job D to processor 2. D is a 12-hour job. That'll take him out to 20. 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. There it is, 20. It's a 12-hour job. There we go. Are we good to there? So far? So far, so good? All right, who's ready? Who's the next one? Oh, that means this guy will continue with idle time. There's nothing for him to do. He's up to 9 hours now, idle time. Nothing for him to do. There's no other job available. Right? You see what I'm talking about? There was only one job, D, and we gave it, you can't split up the jobs. That'd be too complex. We just gave it to processor 2. Okay. So now come up to the next time a job is done, which would be at 9 hours, right? At 9 hours, C is finished. So let's come down here, cross off C. C is finished. D is being worked on by processor 2. So there's the state of affairs, right? At 9 hours, A, B, and C are done. Processor 2 is working on D at 9 hours. So what jobs are available? What jobs are available at this point in time? Can you tell? Only E is available? Only E. Only E, because B and C are done. So now, 2 people are available. Processor 1 and processor 3 are both available, but remember, you always start on the top. So processor 1 will get the job. He'll get the E job. 6-hour job, add 6. That's going to be 15, 10, 11, 12, 13, 14, 15. Right there, he gets job E. Takes him out to 15 hours. Oops, did I get unlined up with the one down below? I don't know, maybe a little bit. Yeah, I should probably be more careful. Keep it lined up, or it'll mess you up. So, let's see. 10, 11, 12, 13, 14, 15. Maybe right there. So, job E at 15 hours. So, okay. And then what's this guy doing? Idle time. More idle time. All the way to 15 hours now. There's nothing for him to do. So we're starting to see that this series of jobs listed in the arrow diagram is not really good for 3 employees, is it? It's a bunch of wasted time when you have 3 employees on it. All right, so keep going. So next time somebody comes to the office with a job, 15 hours, D is done at 15 hours. I'm sorry, E is done at 15 hours. E is done. D is still being worked on by processor 2. All right, so what at 15 hours, both of them are available for another job. Right there, 15 hours. So what job is available at 15 hours? You all with me? 15 hours, only G, huh? Only G, because D's not done yet. So G's a 2-hour job. He'll do G for 2 hours, 16, 17. G, 2-hour job. Processor 1 always goes before processor 3. More idle time for processor 3 to 17 hours now. Yeah.
Oh, I'll let you go on it.
You sure?
Because it's a question about that.
About it. Oh, okay, yeah, let's go. Yeah, so now what's going to happen? So everybody get caught up to there. Everybody good to there? Now, what's the next completed job? You remember, you sort of jump forward to new jobs completed. G. Okay, go up here, cross off G. Okay, there we go. I'm at 17 hours now. You've got to place yourself in time, right? I'm at 17 hours now. At 17 hours, job G is done. What jobs are available? Well, none. D's being worked on. F's not available till D's done. Everybody see that? F is not available until D is done. And at 17 hours, D still has 3 more hours to go. Everybody see that? So there's idle time, even for processor 1, up to 20 hours. And he continues to be idle up to 20 hours. Because there's no job for them to do while D's being worked on. There's no job to give either one of them. Does that make sense? So it comes up to 20 hours, and then a new job is done. Then D is done. Now we can say, okay, now F's available after D is done. Does everybody see that? So the common mistake students make on these is they'll forget about that arrow diagram and they'll put F back here or something. F cannot be started until in time after D is done, right? All right, now D is done. All 3 employees are ready for a job. Who's going first? When all 3 are available, start with the top. Processor 1, he gets job F, a 1-hour job to 21 hours. Processor 2 is idle for that last hour. Processor 3 continues to be idle to the bitter end. 21, we're done. At 21 hours, all the tasks are done. Everybody's finished. There was a lot of idle time up there. Not a very good managed thing. There it is. This is a Caltrans job right here. I can't resist the joke, sorry. Do you know we have a Caltrans, in fact he's teaching probably right now he's just down the hall. It's probably 2 doors down that way. Mr. Kirimakis, he's a great guy, he's my good friend. He's retired from Caltrans. And he teaches math for us now. He's part-time. He just does it. He just enjoys it in his retirement years. Anyway, he was a manager for Caltrans for a long time. And so I grabbed him one time in the halls. I said, Spiros, you hear these stereotypes. So I always want to know, I want to go to the horse's mouth and hear, is it true or false? What's the real story? So I go, Spiros, tell me, is that all those jokes people make about Caltrans? Is that true or is that just false? Is that just, what's the story? And he goes, oh, it's true. He's like, it's crazy there. I try to manage these people. They will never work. He said, I can't fire him. He's a huge employee, so huge company, so much paperwork. You can't fire him. You just move him out into some other department. He said, it's terrible. He verified everything, all the jokes I've ever heard. So he'll deny it if you talk to him. I think he tries to be a little careful, I guess. But I tell everybody, right here on recorded thing even, So I think it's hilarious. Anyway. All right, so there we go. No questions on that? Is that good? That's a long one, huh? All right, I'm going to